So a bit of a recap on the what we call the bits power. Oh, so 8 bits, we have 2 to the power of 0, which is equals to 1. Okay, 2 to the power of 1. Okay, so on and so forth. 2 to the power 1, 2. Okay, until 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7. So we have the corresponding bit value, decimal value. 2 to the power of 0 is 1. Okay. Then 2 to the power of 1 is 2. Then we have 4, 8, 16, 32, 64, and 128. That is the decimal value. And if we sum up everything together, it will give us 255. So this is the bit power. Okay. We call that the bit power. So having understand this bit power is important, because in IPv4 addressing, subnetting, okay, we always need to refer to this table if you are not able to put it in your brain. All right. So in IPv4 addresses, usually we have what we call the classes of IPv4 addresses. So there are a few classes of IPv4 addresses, like we have class A. Okay, class A mainly is 0.0.0.0 to 127. Okay, the network range. Okay, IP range, IP network range. Then we have class B. Okay, class B, usually we have starts from, of course, it starts from 128. Then class C. Class C address space, we will start with 192. Okay. Then we have class D and class E. I didn't put the class there, because they are actually reserved. Okay, reserved for what? Usually, if I'm not wrong, if you remember it incorrectly, class D is for multicasting. Okay, multicasting. Okay, then this one is for experimental, okay, purposes. So this will be reserved. So this one from 128, 28 class C will be 192. So this one will be 191. Okay. This one, basically class D is 224, multicasting start from 224. Okay, so our 192 will be moving on to 223. Okay, all right. And our class E for experimental starts to 240. So this fella will ends at 239. Okay, and of course our 240 all the way will be go to 255. So this is the beginning of a range, okay, and usually we only mess, okay, we'll say mess, only we most of the time we only deal with A, B, and C D and E of course is not in our range unless you are working with NASA or DSTA you are doing some experimental, then maybe you want to go into the class E address space. Okay, so for class ABC are the ones that we are frequently using. Okay, so our, for example, we have an IP address of 192.168.1.2. So this one is actually a class C address space. Okay, and there are what we call the private and public address space across the 3 classes also. Okay, you can use some for private or as netting. Okay, if you have a limited amount of public IP addresses, you may want to have a private IP addresses on that particular class assigned. Then after that, you can take on and map to public IP addresses. Okay, anyway, we don't talk about the public and private first. We just borrow maybe one example here. Okay, like if we have this IP addresses network, okay, like sometimes we have a small company, we set it up, and then we are usually given an IP address from our ISP provider. Okay, so assume our network address is 192.168.1.0. Okay, basically this IP address is divided into what we call the network portion and host portion. Okay, network portion and host portion. So what are the network portion and host portion? So you have to take note for class A. Okay, for class A, our network portion is 8 bits. Okay, the remaining 24 bits are the host portion. So the network part, they call it the network part or the network portion, is 8 bits. The host portion, okay, we have a total of 24 bits. Okay, 24 bits. So 24 plus 8, okay, 24 plus 8 will have equals to 32. So an IP address consists of 32 bits. Okay, but network portion and host portion are divided for that particular sorry, IP address. Okay, so if I have this particular class A, I have a network portion of 8 bits. Okay, and I have a host portion of 24 bits. How many subnets, how many networks I can have, how many number of hosts of IP address I can have for a class A network. Okay, that will give us hold on, just give me a moment, just to make it a bit more clearer. Okay, so that will give us how many for number of networks. Okay, so 2 to the power of 8. To the power of 8, 256. I can have 256 network in the class A range. And how many hosts I can have for each of the network? Well, that's a lot, 24, 2 to the power of 24. Okay, so for each network, okay, number of IP addresses I can have. Sometimes they call that number of hosts I can have, because each IP address will be carried by one host. So I have 2 to the power of 24. You got this amount of IP addresses. Okay. All right. So this is the for class A. Then how about class C? Okay, I don't want to jump. Okay, I just move on. 16. Okay, 16, and then after that, okay, I left another 16 for the host. So this is for class B. So for class B, okay, I have a 16-bit for the subnets. Okay, number of networks. Okay, so in this case, I can have 2 to the power of 16. I got 65,536 number of networks available to create from the class B. I can create this amount of networks, and each of the network I can have the same 65,536 number of IP addresses. Usually we need to minus 2. We need to minus 2. Okay, we need to minus 2. Later I'll explain you why we minus 2. Okay, number of hosts. Okay, minus 2 hosts. Okay, usually we need to minus 2. All right, minus 2 IP addresses. Okay, then for class C, we have 24 bits on the network portion. Okay, and then we got 8 bits on the host portion. Okay, on the host portion. So that gives us 256. Sorry, 24 bits. That will give us quite a huge number of these number of networks. We can have this amount of networks, 24 bits. Okay, and each of the network we will have 256 minus 2 IP addresses. Okay, 256, that is 254, also minus 2 IP addresses in each of the network we created. Okay, why we need to minus 2? Because one IP address is used for the network address we cannot use, and then another IP address, okay, one IP address is used for the broadcast address that we also cannot use. Okay, so basically that's the reason why we minus 2 from each of the IP addresses created or for each of the subnet. So in summary, okay, for class A, we have the least amount of network, but a huge amount of IP addresses we can create for each of the network. For class C, in this thing, okay, we have a huge amount of networks we can create, but each of the network can only contain 254 IP addresses that can be used. Okay, so what kind of scenario usually we have for class A? Class A, like maybe Microsoft, Cisco, very big organization, Apple, okay, Taobao, maybe big organization, few millions of workers, terminals, okay. Then for class C, maybe we have RP, Republic Poly, okay. Even your small home office, okay, can have a class C IP address, okay. So a small office would be in the class C zone. We can have a more networks. Okay, in the world we have smaller organizations, of course, with smaller with that amount of hosts available for use, and we have of course lesser big organizations, very powerful one, Apple or whatever. Okay, but we have more IP addresses that can be used for the company. All right. So at this point of time, everyone is clear about this thing because I'm going to move on to subnetting.